Happy National Flowers Day. Roses are red, violets are blue. I love math. How about you? You guys are looking really rosy today. Let's get to the math. Now, today we're going to talk about bearing, and bearing is about navigating. It's a way to give direction on where your vehicle is going. A way a ship is going, an airplane, and it will give specifics. Often it uses north, south, east, west, but more specifically, you're encompassing degrees as well. What we're going to look at today is going to be how do you label bearing, and it's very crucial because you need bearing to set up story problems correctly. If you don't set them up correctly, there's no way you're going to solve them correctly. 75% of your efforts should be on setting them up correctly instead of solving, just to make sure that you did it correctly. Notice what we have here. We have an acute angle formed by a north-south line. Your focus is going to be on the north-south line now. And you have an east-west line. Whenever you have bearing, you're going to make a cross and show where the line is coming out of. Notice the terminology on here. It says the bearing of B from A. Of B is always going to be where your object is. From A is going to be where the, let's say, the origin is. So you're always going to have an origin, and you're always going to have an object out from the origin. One way to remember, you got to remember that. Of is out from the origin, and from is at the origin. The way that you label it is either north-south, and then the degree, and then east-west. And we'll get back to that in a couple problems. There are a couple little concepts in here that you've been exposed to before, but you still need to know. One is the angle of elevation, the other is the angle of depression. Angle of elevation is elevate. Elevate means to go up, elevator. And so what you're thinking about is starting from the horizontal and going up to the line of sight. So that angle is going to be the angle of elevation. Similarly, angle of depression, you're depressing something, you're pushing it down. It means you're starting from the horizontal and going down to the line of sight. Angle of depression. These are two terms that you're going to want to make sure you use effectively when you're setting up problems. Don't make the mistake on the depression. You may have to draw this line, this horizontal line, outside of your diagram in order to put in the angle correctly. This is just parallel lines cut by a transversal. When you have parallel lines cut by a transversal, you know certain things are true. For example, you know that alternate interior angles are congruent. You know that corresponding angles are congruent. Corresponding upper right and upper right of these intersections. Normally it's going to be corresponding or alternate interiors. You're not going to have a simple problem like this. It's going to be incorporated into a story problem that it's just going to assume that you know that knowledge. You don't have to put this problem in your notes. It's an easy way to solve it, but just know that if you have isosceles triangles, just a quick reminder, those two are congruent. You know these base angles are going to be congruent as well. And so if the question is to solve for x, you're going to know that these base angles are congruent. The height is going to break it into two congruent triangles, and then you have a hypotenuse. And so then you can use SOHCAHTOA once you get the right triangle. So this would be easy because it would just be the sine of 52 is x over 24 solved. I'm going to assume now that you know how to use SOHCAHTOA since we've had enough practice with it. main focus today is going to be the setup of the problems. I want to just show you a couple things on the examples. I don't want to solve them, but I just want you to get a general idea. And on example number 2 in your book, on page number 85, you're looking at the angle of elevation. And so often is the case, you will see a flagpole or some tree with a shadow, and you're seeing from the earth up is the angle of elevation. Remember, that would be an inverse trig function because you're solving for an angle. You would always set it up as the tangent. So it'd be just setting it up. Tangent theta is equal to 75 over 43. And then you would, in the second step, rewrite it by using inverse trig functions. And then go ahead and solve that. But again, you want to do these 2 steps. Do not just jump to that second one. Example 3. Example 3 is talking about a pyramid, and it says on that pyramid that there's an angle of depression to a starting point, which is 52.6 degrees. Now, be careful with this because the angle of depression is where it's horizontal down, so it's outside of the triangle. 52.6 degrees. And also notice that if you were to use a right triangle here, that this angle here is the same exact angle as that one there because those are alternate interior angles. And when you put this as 52.6, now you can use the inside triangle and get your answers from that. So that's a time when you can use alternate interior angles. Then we have a story problem about California, some cities in California. And this says SLO, California, is 12 miles due north of Grover Beach. If Arroyo Grande is 4.6 miles due east of Grover Beach, what is the bearing of San Luis Obispo from Arroyo Grande? Now, that's a lot going on in this story problem. You're going to have story problems that if you read it one time through, you're going to be like, where do I even start? The place that you start on these bearing questions is to drop a north-south line, and that can get you in the right direction. So that's what we're going to do. We're going to drop a north-south line, and I'm going to draw this very carefully. It says, SLO is 12 miles due north of GB. That means I'm going to put SLO at the top and GB at the bottom. And I'm going to label it as 12 miles. I no longer have to look at the first sentence because I just drew it. Second sentence, if Arroyo Grande is 4.6 miles due east of Grover Beach, here's Grover Beach, due east is at a right angle, so that means it's going to be 4.6 miles. I now have the second part of that drawing. I don't have to look at that part, so now I'm right here in what I need to do. Make sure you label what you're trying to find. What are you trying to find? You're trying to find the bearing of SLO from Arroyo Grande. The bearing of, here's my quote words, of and from that I want to think about. From, I like to think about, is the base, the anchor, where I'm starting from. So whenever you see the from and I want to find a bearing, I would always just do a quick north-south line at that point and then draw it in. So from AG to SLO means I need to connect those. And my bearing, remember, has got to be off of the north-south line, which means this right here is what I'm trying to compute in my data. I label the angle that I want so I don't get confused in the problem. At this point, I don't have to look at the words at all. My drawing has everything labeled in it. I now go and try to solve for what my data is. How do I do that? You could get this angle and subtract it from 90 to get your theta, or you could use the fact that these are alternate interior angles again. These are verticals, they're parallel, alternate interior angles give you theta. Theta, now we can use in that triangle, again, opposite over adjacent is tangent. Writing this down, tangent theta equals 4.6 divided by 12, and then you're going to use the inverse for theta. When I do that, I am not done with the problem, because the problem is asking for the bearing. The bearing is not just my angle. I have to put it in the right form. So when I'm looking at this angle here, what I really want to do is write it down as north. And then what I want to do is say that it's going to be 20.97 degrees. And then I want to do which direction it's going to be to the west. And that right there is the bearing. Don't stop short. Make sure you're answering the question on bearing. This is an easier problem. Where we're going with this is you're going to have a ship that takes off at a certain bearing, goes a certain miles, and then all of a sudden changes its bearing and goes to the other direction. And then the question is, how far did it travel? What's its new bearing? So that's like two bearings in one problem. So these story problems are going to get complicated. We want to get the basic stuff. Let's go to the last problem. And this problem says, and I'll just write down the key information here, a boat travels on course of a bearing of, so I'll write down the bearing, north 52 degrees 40 minutes east, for a distance of 238 miles. How many miles north and how many miles east has the boat traveled? Again, this is all preliminary stuff to make them more complicated. First thing I want to do, make a diagram. Make an accurate diagram, show what I want in the diagram. So, gives me bearing. First thing I do, drop a north-south line, or you can do north-south, east-west. And this one says that it's traveling north 52 degrees 40 minutes east. You're going to have something that looks like this for 238 miles, and labeling that angle as 52 degrees 40 minutes. Be careful, 40 minutes does not mean 0.40. The question, how far north and how far east did this boat travel, means how far north and how far east did it travel. once again, you could take these two as parallel lines, and I could mark this right here as 52 degrees 40 minutes. And now I can work within the triangle that I have. Or you could find this one, subtract from 90, and get, or you could subtract this from 90 and use this angle to get your north and your east. So now you have two equations. You have the hypotenuse that's given, you have your angle that's given. So we're looking at the sine of 52 plus 40 divided by 60, because I just converted that into a decimal of a degree, is equal to the opposite e over 238. At that point, you can solve for your e, and the other one is going to be the cosine. You can see these story problems are getting into nature a little bit. We've got boats, we're going to have planes, we're going to have a lot of different objects flying around out there. So we've got to get the right diagrams to help you solve these. And then you'll be able to see the light and good luck with the section.